Welcome to the House of Code. In today's video, we are going to learn how to solve this problem. So the problem is squares of sorted array. So let's see how we can solve this problem. So what is the problem statement given to us? Given an integer array num sorted in non-decreasing order. So we have been given an array which is sorted. Return an array of the squares of each number in non-decreasing order. So we have to return the square of each number, but that squares of each number should be in sorted format. So let's see what is the example given to us. So example, this is the array given to us: -4, -1, 0, 3, 10. So as you can see, this array is sorted in non-decreasing order. The output expected is 0, 1, 9. So basically the squares, the square of -4 is 16. But the 16 is not is the first element of the array, output of the array. So we need to sort it after getting the squares. So as you can see, 0 square is 0, 1 square is 1, 9, and the array output array is also sorted. So we have to return the sorted output of the squares. So after squaring, the array becomes this, and after sorting, it becomes 0, 1, 9, 1600. Now, what is the simple thing we can do? Just find the square of the array and use the sort inbuilt function. This will solve the problem in 2 minutes. But the time complexity of this code will be O of n log n. Since O of n log n will be this time complexity of sort, it will take maximum O of n log n time, worst case time complexity. But the space complexity required over there will be O of 1. Now let's see how we can solve this problem using a two-pointer approach. So let's move to the whiteboard to see how we can solve this question with a two-pointer approach. Okay. So let's say this is the array given to us: -4, -1, 0, 3, 10. Now let's first find the square of each element. So -4 square will be 16, -1, 1, 0, 3 square is 9, 10 square is 100. So this is the this is the square of all the elements, but this is what the output is expected. No, the expected output is, we have to sort this. So after sorting, what we'll get? 0, 1, 16, no, not 16, 9, 16 and 100. This is what is expected. Okay, now how we can solve this problem? So this is the first thing we will do is find the square of each element. How we can do find the square of each element? It's simple. Just have a for loop. For int I is equal to 0, I less than n, I plus plus, and in each position just have the array. Nums of I is equal to nums of I into nums of I. So this will help you to find the square. So now our nums of I array will look like this. Our nums of array will be this. But can we return this as a sorted array? So no. So what we can do is, we will have to use two pointers approach. Now how we can use the two pointer approach? So if you start directly implementing two pointer approach on this array itself, it will not work. You will never find the correct solution for that. The key point or the key takeaway in this question is, to solve this question with a two pointer array, you need another array of same size. Let's say we have another array vector int. Let's say we are our this another array is result. Now this array should have same size as that of our array which is given in the input. So what we can do, we can initialize this result with the same array which was given to us in the input. Now, but here already I have performed the square of an array for all the elements. So what result will store is, result will have this data set: 16, 1, 0, 9 and 100. Okay. So this is what result will be holding initially. Since after finding the square, we are initializing that vector. If you are initializing vector before this for loop, then it will have this element -4, -1, 0, 3 and 10. But we have updated the array, input array by the square of it. So the result array will also store the this implemented square array. But it is not sorted. Now we need to sort it. So how we can do? Let's have our pointer int I is equal to 0. Int j will be at the end position nums dot size -1. So what we will do, while I less than or equal to j, what I am doing, I'll have I over here, j over here. So 16 and 100 I will compare. What I will do, I'll compare. If j, not j, value in the j. Sorry. If, wait, I'll write it over here. It will not be visible for you. So what we'll do after initializing, while, since I should be less than or equal to 0, till that time only it should go. If nums of I is greater than nums of j, we have to perform something else. Now let's see what we can perform in that else part. Okay, now nums of I is 16. Nums of 100 is, j is 100. So 100 is greater or 16? 100. So what we will do, in the new array which we have created result, we will add that 100. So result of, we will have one more pointer, say, let's say int k. K will be pointing to the end of the new array, result dot size -1. So k will be pointing over here in this array. So my result of k will be equal to which one? J element, right? So it will be nums1 of j, nums of j, not nums1 of, nums of j. Then what we have to do? We have used the j. Now here 100. So we will place 100 over here. 100 was already there, but it will still replace. Then we will decrement the j. And this we filled it, right, with 100. Now we need to fill other elements. So we will decrement the k after adding that element. So we will here directly do k minus minus. This means first value will get stored in the k and then we will decrement the k. So k also got decremented, j also got decremented. Now between 16 and 9, who is greater? 16. That is nums of I is greater than nums of j. So what we will replace result of k with? Result of k we will replace with nums of I. Okay. Now we will replace this 16 and 9 by 16. Since 16 was greater than 9, so we will have 16 over here. And we have to increment the I since we already utilized it. And we have to decrement the k so that we can write into next element. So my k will be at this position. Now I will be at 1 position. Now between 1 and 9, which is greater? 9. So now we will, what we will do? We'll replace the kth value with 9, increment the k, then we will decrement the k. Okay. Now nums of I is greater than nums of j? Yes. So we will replace this with 1. This k was already decremented. 1 will be replaced by 1. Then we will increment the I. Now we will be at 0. Okay. Nums of I greater than nums of j? No. But it is equal. So it will go to else part and 0 will come over here. K minus minus. So if you see, I and j iteration is finished, and if you can see, we have got sorted array 0, 1, 9, 16, 100. So this problem we have solved using which approach? 2-pointer approach. It was very easy. The all thing you have to understand is, first create another vector of same size to store the result. Second, like after, if the element is greater, put that element behind first, then you can go for smaller elements. Like start with larger elements and start decrementing the new array. And can you tell me what is the time complexity of this code? The time complexity of this code will be, this for loop will take O of n. This while loop again will take O of n, since we are going for all n elements in worst case scenario, if else. So time complexity of this is O of n. What will be the space complexity of this code? Are we using any extra space? Yes, we are using extra vector to store the array. So we will have space complexity of O of n, and we will return that result array to print the output. So let's see whether this code actually works. It was very simple code. The only key point is to add a new array. Let's write the code. The expected output is array. So we will create one array with name result. Okay. After that, we will find the square of all elements and store in that array. Size I plus plus. Now what we will do? Nums of I is equal to nums of I into nums of I. Now this is how I have found a square and stored it in the same array itself. Now we will have for loop. No, not for loop. Then we will have variables. Int I will be pointing to 0. Int j will be pointing to num dot size minus 1. Then what we will do? Then while I less than or equal to j, if nums of I, that is left element, is greater than nums of j, that is last element, then what we will do? Result of k. What will be the k? K will be one variable pointing the end of the array, and k is equal to nums dot size minus 1. ठीक है? While k, result k is equal to nums of I, we will increment the I. K should be also decremented since we have already filled that position with greater element. Else, that is, then my j element is greater than nums of I. So what we will do? Result k minus minus, instead of I, now we will put j, and here j should be decremented since it is pointing at the left pointer. Okay, so this is the while loop. After while loop, what we will do? We will return the result. So what we are gonna do? We are gonna return result. So this result will have all the square of sorted array. Here it will be nums dot size. Here you can have k size as num dot size or result dot size because both have same size. So it doesn't matter whether you write here nums or result, but for your clear understanding, I'll write a result over there because this pointer is pointing to the result array. So let's see. Oh, we got runtime error. Applying non-zero offset to null pointer. So here I have written over here result, but we have to initialize this result with the array. So we will do that. Now instead of writing over here, I can also write below the for loop. So now the result vector have all the squares, but they are not in sorted format. Then we implemented a code for which it will get sorted. So let's see. Oh, so our test cases are getting accepted. As you can see, this is a case 1. As you can see, output and expected output is equal. Then this is case 2. It's equal. Good. Let's submit the code. Yes. So time and space complexity of this code is time complexity O of n, space complexity of O of n. Yes. So thank you for watching this video. If you have any doubts, let me know in the comment section. And if you want to see more videos on 2 pointers like this, you can refer to our channel, and you can see there are many questions like this which we have solved on other data structures and data patterns. You can look into that. Thank you for watching this video.